Okay, so now we're taking a look at these last type of problems, which are definitely more complicated. These you will see in the homework, but you will not see on uh, your upcoming test. These we will focus more on later. We actually have another uh, unit or another section later on called Trig Equations Part 2, where our focus will be more on these kinds of equations then. But you do have a couple of these in the homework. And so I do want to take a look at one of these so that to help you out with the homework. So here we have cosine squared minus sine squared plus sine. So I actually have a mixture of two different trig functions. Uh, Now, if this was just sines or just cosines, we have ways to handle that. As it is with a mixture, we have to use one of our trig facts from before, and that is this relationship. And you will find in the upcoming sections in the next chapter that we find ourselves using this relationship a lot. Cosine squared plus sine squared equals 1 allows us to manipulate expressions involving sine and cosine to change how they look. And that's exactly what we're going to do here, because we can take this thing and solve it for cosine squared. You can get that cosine squared is 1 minus sine squared. So that I can go into this upper equation here now and replace that cosine squared up there with this expression. And so I do that. And I get 1 minus sine squared minus sine squared plus sine equals 0. And so now I do a little bit of rearranging. So I have some like terms here. So 2 sine squareds. So minus sine squared and minus sine squared will be minus 2 sine squared plus sine plus 1 equals 0. Okay. And then there's one further thing that we do here. I want to make an adjustment, and then we're going to change this equation. And that is the squared part's negative, so I'm going to multiply the whole equation by a negative 1. And that'll give me the equation 2 sine squared theta minus sine theta minus 1 equals 0. And then what I'm going to do here to be able to solve this equation is recognize that this is actually a quadratic equation in terms of the sine function, not in terms of a variable, but in terms of the sine function. So I come in here and say, let's let u replace sine theta. And then that gives me this equation here, 2u squared minus u minus 1 equals 0. And since that's a quadratic equation, we can solve it for u using the quadratic formula. And then once we have answers for u, we can then go back and solve to find out what theta has to be. Right, so what we're going to do now is take and use our quadratic formula. So u equals the negative of b plus or minus the square root of b squared minus 4 times a times c all over 2a. All right, so we go through and simplify. Uh, Negative of negative 1 will be 1, plus or minus. On the inside, we're going to have 1 squared, which is 1, plus 8. 1 plus 8 is 9. Square root of 9 is 3. So on top we have 1 plus or minus 3. all divided by 4. And then we work those answers out. 1 plus 3 is 4, divided by 4 will be 1. And 1 minus 3 will be negative 2, divided by 4 will be negative 1/2 when we simplify. So those are our two answers for u. But now we need to go back and solve not for u, but for theta. So we go back now and write down the equation. Sine of theta equals 1, and sine of theta equals negative 1/2. Okay, and we solve both of those equations. So sine of theta equals 1. That is a quadrant value. So we're back to our unit circle. Sine is the y-coordinate, which would be 1 up here at pi over 2. So one answer here is theta equals pi over 2. For the second one here, negative 1/2 is one of our exact values. Or sorry, 1/2 is one of our exact values. So we figure out the reference angle. For 1/2, that would be pi over 6. But since sine is equal to a negative answer, we take that and put it into the quadrants where sine is negative, which would be the third and fourth quadrants, so that we would get theta equals 7 pi over 6 and 11 pi over 6. Okay, and so we have these three solutions for that polynomial equation involving our trig functions. And so again, just to kind of recap, when you encounter an equation like this with a mixture of sines and cosines, really our only option is to, right now, is to use this type of process to convert over so that it's just in terms of sines and cosines. And when you do have an equation, or just in terms of sines, sorry, when you have an equation that is like this, a polynomial in either sine or cosine, we can let u take the place of that trig function and then solve the quadratic equation. Once we solve it for u, we then backtrack and solve for our angle theta. Okay, again, these are ones that you're going to see in the homework. They will not be part of your exam during the this upcoming exam for this unit. We will see them again later, but I want you to see some of them now, just so you can get a little bit of practice working with those.